So good afternoon. We'll be starting with the question units and measurements. Okay, that is going to be our first important chapter over there. Can you do me a help? Okay, so the first chapter given in your textbook is actually physical world, but that chapter is actually not required for the exam point. Okay, so I will just summarizing you about that chapter, like while we revise the topic. But now we'll be starting with our main chapter, that is units and measurements. Okay, so speaking about units and measurements, the first chapter which we are going to learn in 11th standard, if people know how important your 11th standard classes are going to be, it is entirely different from what you have studied in physics in your 10th standard, up to your 10th standard. It was just a sub-subject inside science, right? You had a single text having three subjects: physics, chemistry, and biology. Only 3 to 4 chapters from physics for the entire year, right? Now we are going to study about 14 to 15 chapters for the entire year in physics only. Similarly, in chemistry and then in biology or computer science, whichever you take. And this is the first chapter which we are going to study about units and measurements. It is an easy chapter, comparatively easy chapter. It is easy and simple to study, but there are some things which you have to memorize. There are things to memorize. Yes, it is there, but still, this chapter will feel a bit like, okay, what is this? What is that? Like a kind of such thing will be there in your mind. But the thing you should know is each and every term you study in this chapter, you will require it for the entire 11th and 12th, especially for the 11th. Okay, so for all these chapters, you will be having several terms. Say, for example, you are having a chapter named systems of particles and rotational motion. Okay, that is coming almost the last or second last chapter in your first text. And in that chapter, you are having a term moment of inertia. So you will be studying what moment of inertia is only there in that. But here in this chapter, you will have to study the unit and dimension. So such kind of an anomaly will be there. Yes, but still you will have to memorize it now. But when you study that chapter, there is no need to memorize. For the final exam, you actually do not need to study this. Okay, well, because you're studying all these portions, means you will automatically study this. Okay, so that is the case over there, and we'll be starting with the chapter. So first of all, about units and measurements. So for what kind of applications are they using this units or this measurements? To calculate anything. To calculate means, is it to calculate a measurement? Why should we take a measurement? Or for what kind of a thing we are taking a measurement? Quantity of a particular thing, right? That means we are having a particular object for which we are having a physical quantity. So we'll be calling it as a physical quantity. Okay, so we are having quantities in which we can have physical measurements, means it is called as a physical quantity. So measurements and units are all associated with the physical quantity. So what is a physical quantity? Any quantity that is having a physical existence is called as a physical quantity. Okay, so any sort of a measurement that can be made on a physically existing substance can be called as a physical measurement. Measured is called a physical quantity. Okay, so anything that can be measured can be called as a physical quantity. Anything that can be measured is called as a physical quantity. Got it? Okay, so that is the case over units and measurements introduction. Okay, now what is a unit? What is a unit? See, if you are asked to measure the length of a table, okay, you are given a table or a line, simply a line is given to you. The line's name is AB, and you are asked to find the length of this line. What will you do? You'll use a scale, right? You'll use a scale or you'll use some other devices like a tape or something to measure the length of the line. And you will say that if I am saying it as 15, does it make any sense? It can be 15 centimeter, it can be 15 meter, It can be 15 kilometer, it can be 15 millimeter, anything, right? So specifying the unit is very, very important to understand actually how much there is the physical quantity there. Okay. So if I say it as 15 centimeter, then it will be, got it? So unit is anything that is accompanying this particular, no need to write, no need to write. I'll be telling you the exact definition, I'll be giving you the exact definition. You need to write this. Unit is something which is accompanying the physical measurement that will convey you the state at which we have to measure or the scale at which we have to measure. So scaling something you might have seen the map, the world map given to you, right? Is the world actually there only up to that scale? No, right? We are scaling the entire world into a single paper or to a sheet so that we can see the entire world in a single paper, right? So that is the process of scale. We are converting these units in kilometers to centimeters or millimeters so that we can scale it into a particular smaller frame. Okay, so that is what we are doing in scaling. Okay. So any unit that accompanying this particular physical number, the physical measurement or magnitude you have taken is very, very important. Why? Because then only we will be able to understand the scale of measurement that we are doing. Okay, so that is the importance of unit. Now about measurements. So taking the measurements is very important, right? Because we don't have to make any mistake in making the measurements, right? If we make some mistake in taking a particular measurement, means what will happen? The wrong number which we get, or physical measurement which we get is going to be wrong, and this can also affect the further calculation. See, for example, if I am finding the length and breadth of a particular table, okay, I found the length with a small error and breadth with a small error. Now, if I go for finding the area, it will have a larger number, right? Why? Because if we have a length in error in the length and error in the breadth, when we go for multiplying them, the error is also accumulating, right? L times B. So L is having error, B is having error, means that much time the error will multiply or add up, right? So if we make measurement in taking the measurement, error in making the measurements, then the calculations will also have greater errors. So whatever we find out from the wrong measurement will give you a wrong answer to the particular quantity. Got it? So that much important it is for measuring a particular measurement. Okay. Now about the different physical quantities we will see. Okay, so physical quantities are basically of two types. Yes, physical quantities can be divided into two. So if I write physical quantity like this, it can be of two types. Okay, so it may be a fundamental physical quantity, or a derived physical quantity. Okay, fundamental physical quantity and derived physical quantity. So what is a fundamental physical quantity and what is a derived physical quantity? So any physical quantity that is directly obtained from a measurement. Say for example, length, mass, time. All these are directly measured from a particular like if it is a measurement of length means we'll be having a device, a scale or a tape or something. We'll be measuring that particular length, right? We do not require any equation to find it out. We can directly measure it from the field. That is what is called as a fundamental physical quantity. Time. I can see time in a watch or clock or a time or a stopwatch or something. The device can be used to directly give you a particular measurement and you do not need to do any further calculation. Then it can be called as a fundamental physical quantity. What are the examples of fundamental physical quantity? Mass is an example. Length is an example. Time is an example. Temperature is an example. Then, yes, luminous intensity. We call it as luminous intensity. Then, yes, current is an example. Yes, amount of substance is also an example. Okay, so all these comes under fundamental physical quantities. Now about derived physical quantities. So what are derived physical quantities? obtained from the fundamental physical quantities. If we operate between the fundamental physical quantity and we get some physical quantity, means that can be called as a derived physical quantity. Those are derived from the fundamental physical quantities. Can you give me some examples? Yes, speed equals distance by time. Distance means length, right? Yes, distance by time. So distance, if it comes under length, time comes under this particular thing. So length by time or distance by time will give you velocity, right? So speed or velocity is an example. Then area is a very good example, right? Yes, acceleration is an example. Then weight is an example. Then force is an example. Then density is an example. Volume is an example. Then work is an example. Energy is an example. Power is an example. Heat comes under an energy, na? Heat or energy can be called. Then inertia is actually a property. See, for inertia, we do not have a particular measurement, but we have measurement for moment of inertia. That's what I told earlier. In the systems of particles chapter, you have moment of inertia. So you have, yes, moment will be there, momentum will be there, moment of inertia will be there. Then what else? Acceleration, area, volume, then many are there. Lot of them are there. If you derive stress is there, strain is there, pressure is there. See, all those things are there. Frequency, yes, frequency is there because it's reciprocal time, na? So we can do it. And there are a lot of physical quantities which we can part of the resistance. Resistance, yes, resistance of course, because you have resistance equal to V, R is equal to V by I, right? So we can derive it as such. Then resistance. Sure. Resistance is there, conductance is also there, resistivity is there, conductivity is there, then voltage is there. All those things can be said under derived quantities. Okay. So this is the basic difference between the fundamental quantities and derived quantities. That uses no, we do not have to study them. Luminous intensity actually yes it is there. It's not like it is not there, but it is not there in your quantities. When I did my 12th standard project, it was based on light dependent resistance. So for that, I required a device called a lux meter, which used to measure the intensity of the light. But actually, that was not available during the time when I studied my 12th standard. It was not available around me. So I had to go for taking different bulbs of different voltages. So voltage was taken as a parameter instead of luminous intensity. So it is actually a sophisticated technique. So we require more devices for it to measure. So that is why we do not use it usually in our day-to-day. That's it. So these are basically the fundamental and derived physical quantities. Okay. So now we'll be learning about the different measurements, types of measurements. How are we going to measure them? So the most important fundamental physical quantity which we have to deal with are mass, length, and time. This will be the most important one. Okay. So we'll be dealing about how we measure each of them. What are the different units of them? What are the devices used to measure them? And then we'll be moving on to the concept of dimensions. Got it? Okay. Now your class started in this school? Where did it reach up to? Oh, it went after this chapter. So we'll be moving in a speedy manner so that we can reach that. Okay. So how are we going to measure this particular mass, length, and time? Okay. So first of all, I'll be dealing with the measurement of length. Measurement of length. So what are the devices which we are using to measure length? Yes. That is the unit. Now, I'm just talking about the devices. Okay. Scales can be used, right? Yes, meter scale can be used. Then measuring tapes can be used, right? Measuring tapes. Then give me some other examples to measure length. Meter? Scale itself. Ruler itself. Yes, ruler itself comes under scale only. You can write it also ruler. Then handstands. Handstands are there. They're not exactly. if I have to measure the distance from here to Jayanagar, what do? You go with an address scale? No. And maybe measurement techniques for that. You have to measure the distance from here to Silpur. How are you? Basically, just think your day-to-day life. Your father is asking you, your mother is asking, your friend is asking you. Even I am asking you because I am not a native there. I am asking you, how much kilometers is there from here to Silpur? So how will you tell the answer? You legally? Yeah. Taking it as well. Yeah, you'll be googling it, right? So you'll be having the Google map over there, right? So you will be telling you like 3 kilometers or 4 kilometers will be telling you, right? So Google Map is working based on GPS, right? Yes, it is because satellite only, and that technique is called GPS. It is global positioning system. Okay, so what global positioning system does is, it will be having a satellite over here. It's giving you this information, additional information only, but you have to know it. Anyways, you are studying it, huh? You have to know it. So there will be a satellite over there. Here will be the Earth surface. So here will be the place at which we are setting, and here will be some other place whose distance we have to know. The distance between these two we have to know. Okay. So what we'll do is, when we connect to the GPS or to the Google Map, the signal is getting transmitted from our phone to the satellite. Okay. So the signal gets transmitted from our phone to the satellite. Okay. So this transmission will let the satellite locate us. So our location is fielded to the satellite. Okay. And then what they do is, the place which I first, the satellite will be sending signal to that particular place. Okay. So that particular place, the signal will be sent. Okay. From this, now they'll be able to calculate the distance between this and this. This is the general working of a GPS system. But actually, this is not the entire technique of this, like explained here, by, because we are having roadways. Some roads will be like, if we have to connect from this position to this position, the road won't be like this. The road will be like this, and this. Okay. So this distance is actually being shown in the GPS. Several other coding and software are working behind that. That's why it is happening. So the general idea is this only. The satellite will be sending signals to both these places and identify the lateral distance between them. Okay, and then that will be conveyed to us. So that is the system of GPS. We can use GPS to find the distance between two places. And then any other technique? Any other technique? You just took a car and you traveled from here to Jayanagar. Okay. And the initial reading which was shown in the odometer was 12621. And once you reach Jayanagar, Silpur is. And once you reach Silpur and you came to see that the odometer reading has changed to 12625. With these two readings, you will be able to find the distance between these. The final reading minus initial reading, you'll be able to find how much distance you have covered. So this reading, that is the reading from the odometer, will help you find the distance, right? So odometer is another device that can be used for measuring the distance. Odometer is the like distance measuring device that is placed inside your car, bike, or something. Okay, it will be there. So odometer will be there. So these are the measurements taken for the larger ones, right? Large distances. That is calculated in a unit called light hour, IPS resource. That is by let's see, we'll be having an L2 transmit delay. Usually I'll be helping you with an example. And like when we study for engineering, we'll be having a device called total station. Total station. Total station is a device that uses light as its distance measurement. So this total station will be present over here. We'll be having a standard order for that. This is a sophisticated instrument, and it will be having a light transmission from here. Okay. So this is a particular wall or something which is present in a particular distance apart from this device, and I need to calculate the horizontal distance between these. So what will I do is I will turn on this device. There will be a laser lamp, and this laser lamp will be lighting up the particular and this light is transmitted to this end. On striking here, it gets reflected back. Got it? It gets reflected back and reaches this particular source. So this particular device knows the velocity of the light. Velocity of the transmitted signal. It knows it very well. Yes, that is the light instead of light in air position. Okay, so if I use a laser lamp, it will be. If I use some other UV or something, this field will be different. Okay, so for each and every one, this field will be different. Speed changes. Speed changes to maybe yes, of course, right? Because we have the relation of E is equal to mu lambda. We are having it, na? So if mu or lambda value changes, means velocity will also. Okay. So if I go for some X-rays or gamma rays or something, velocity will be different. For laser, the velocity will be different. For UV or IR, the velocity will be different. So particular light will be lit from this particular device whose velocity is already known by the device. Now, the transmission time is recorded by the device because the device knows when the light is transmitted, when it came back. So it went there and came back. So the half of the time will be taken for this light to go from here to here, right? So if it took a total of 0.2 seconds to do there and come back, it will be 0.1 seconds to go there. The rest of the 0.1 to come back, right? So the time taken for the travel will be 0.1 seconds. Velocity is also known. So velocity is known, time is known. How will you calculate the distance? We know that velocity equals distance by time. From that, distance will be equal to what? Velocity into time. So using this equation, this device will calculate the distance and it will be shown in the digital measurement, like reading over. Okay. So like that, we'll be able to get the distance, horizontal distance. We will be able to calculate the vertical distance also. So the light will be transmitted first to this point A and then to this point B. Then with that, they will be able, the device will be able to find how much is it. So this is such a very efficient device. It is very costly also. So this device is also used for distance measurement. Okay. So that is another example. And another important device, like all these devices are used to measure bigger measurements. If you have got a very small measurement to measure, say for example, you have to measure the diameter of a tumbler. Or you have to measure the diameter of, have you heard of calorimeter? Calorimeter. Calorimeter is nothing but just a golden or like copper colored tumbler shaped substance. It is actually used for calorimetric experiments which we do for thermodynamics or thermodynamics yes, thermodynamics it comes like all the measurements or all the experiments under thermodynamics use this calorimeter. Specific capacity measurement is one of the experiments among them. Okay. So we'll be using calorimeter for thermodynamic experiments. Okay. So calorimeter is nothing, it is just like a tumbler which is having some copper or shiny appearance. Okay. So if you have to measure the diameter of this particular tumbler, okay, it is a glass tumbler or a steel-like tumbler, and you have to measure the diameter. So how will you do it? Is it possible to measure accurately with steel? No, right? Because we don't know the exact center. So what we do is we will be using a device called as vernier caliper. What is it? Vernier caliper. So vernier caliper is some device which is having its shape is like it will be having a main scale over here. This experiment, yes, you'll be having laboratory experiments. There will be a main scale and there will be a small scale inside this called the vernier scale. Okay, then you will be having two holders over here, and these holders will be used to hold inside this glass. Okay, so the glass tumbler will be placed like this. Okay. It will be placed like this. Okay, so this distance now will be able to measure it from the main scale and vernier scale. Yes, cylindrical ones will be there. Then have got a ball like a shot or cylindrical shot or something. You'll be able to place it in between this particular area so that you can find diameter. Okay, so you'll be having two scales over here. A main scale will be there whose reading is called as main scale reading or MSR, and a vernier scale will be there whose reading is called as VSR. So from the device which we take and the like whose measurement is to be taken, we will be able to find the main scale reading as well as the vernier scale reading by observation, physical observation. Okay. And once you get the MSR and VSR, we have got an equation to substitute. What is the equation? It is MSR plus VSR into LC. So who is this LC? LC is the least count. So what is the least count? Least count is the smallest distance that can be measured by using a device. If it is a vernier caliper, then its least count is 0.01 centimeter or millimeter. It is centimeter. 0.01 centimeter will be the least count of the vernier caliper. Okay, so this particular equation, this least count will be substituted by this. Then this MSR and VSR will be able to measure from the scale or read from the scale, and you'll be substituting it in this equation. You'll be getting the exact value. Okay, so this is the device called as vernier caliper. So it is used when you have to measure the diameter of a tumbler or something like that. If you have to measure the diameter of a spherical body or a metallic board or something, then you can take it for measuring the thickness of some book or something. If you have got a book, you have to measure the thickness of the book, means you can use vernier caliper. Okay, such kind of application could be there. If I am asking you to measure the thickness of a paper, or if I am asking you to find the thickness of a metal sheet, can you use vernier scale? Why? Because the vernier scale reading can be read you only a minimum reading of 0.01 centimeter. You know, very less, and even it is less than 0.01 centimeter. And that device is exactly what? Screw gauge. We call it as screw gauge. So screw gauge is a device that looks like a small screw actually. Okay, so it will be having a portion like this, and there will be something like a question mark over here. Okay, and you will have a short from here also, and you can place the substance in between this. Okay, whosoever thickness is to be measured, you can place it in between these two hands. Metal wire will be there, metal sheet will be there, even paper thickness actually it will be somewhat anomalous, but still you can find it somehow. So all those things you can anything whose thickness is to be measured, you can place it in between these two. Okay, so once you place it, this particular thing will have two scales over here. This like vernier scale and wheel scale in the vernier wheel. Yes, there is head scale. Head scale is there and a pitch scale is there. What's it? Pitch scale. Got it. So coming to the equations, like the MSR, we have PSR plus HSR into S. Okay, so PSR and HSR we will be able to read it from that particular scale itself, and then we'll be substituting them. And what is the least count over here? It is 0.01 centimeter. The other one was centimeter. Now it will be what? Got it. It is again 10 times more precise than vernier. Got it. So that is how a zero error is there will be coming to. Zero error actually you have to study it in the lab. I do not have to study. You have to study it in the lab, because once we have an instrument only we'll be able to see it. So I can just explain you why, because it is not only for these devices, for any device. If you try for doing that electrical measurements and all coming up in the next year. The next year you will be having experiments regarding electricity. Okay. In that you will be using devices such as voltmeter, ammeter, galvanometer, etc. Okay. In these things now what happens is voltmeter, actually the reading should be started from 0, 1, 2, 3, 4 like that. Actually without any connections provided, the arrow mark should completely point towards 0. That is the rule. Okay, then only we can say that this particular device is exactly correct. It is not having any zero error, no error in the 0. But what happens is once we start using the device for a lot of time, due to some sort of internal errors or due to the manufacturing or due to sometimes we people are using it, and we'll be trying it for different experiments and we'll be damaging that device. So due to this damages, what happens is sometimes the zero needle will be shifted to somewhere else. Okay, it will not be standing there at the 0. Instead, it will be standing somewhere in front of the 0. Okay, so it is actually not at 0, no? It is somewhat shifted from 0. So this particular reading, or how much it is shifted, now that is called as the 0 error. So whenever we take a particular reading over here, we have to subtract the 0 error from. Okay, so coming to this skew gauge also, you'll be having 0 error, or to vernier also you'll be having. So you have techniques to find out the 0 error for both of them. So you have to find it out and add it or subtract it accordingly to the application. Okay, sometimes we have to add it, sometimes we have to subtract it. Okay, so it depends on the case. So such kind of errors may occur in the device, not only in like screw gauge or vernier, but also in all these electrical devices. Actually, in ammeter and all, sometimes when we look at the device, right, we'll be shocked, right? Because the reading will be somewhat like this. It will be before 0. So how much it is shifted, that much should be added to the reading which we get. Okay, then only we'll be getting the accurate value. Okay, so all those things will be there when you come to measurement. So measuring a particular physical quantity is not that easy. You have to consider many different factors. It may not be your mistake, but the mistake of the device that will give you a wrong answer. If you get something wrong, means what will happen? You get the entire studies wrong, you will get the entire experiment wrong, and the calculations done from it will also get wrong. You get it? So all those things you have to keep in mind while making any measurements. Got it? So this is another device which is used for measuring distance. And you have that electrons and all, electrons, protons and all, you will be identifying the diameter and distance between the electrons and all. How are you doing it? You will have electron microscopes, right? Electron scale microscopes will be there, and within that there will be scale readings which you can measure that kind of very small measurements. Like atomic level measurements can be measured by using electron microscopes. Okay, so those kinds of devices will also come under the measurement of length. Okay, so odometer will be there. Then coming to smaller measurements, there will be vernier caliper. Then there will be screw gauge. Then even for smaller measurements, you will be having electron microscopes. Okay. Actually, that particular thing you did not actually study. I just made it to you because such a device is there. You should know it. That is why it is not given in your textbook. But it can measure everything. It's an all-rounder for a civil engineer. Right? Because it measures angles, it measures horizontal distance, it measures vertical distance, it measures elevation, it measures everything over there. Because it is making use of light. Light has immense capacity. So we utilize, we actually exploit light out of it so that we can get any measurement that is possible. Angle between 2 points, distance between 2 points, like everything will be measured with our precision. So that is a very intelligent device. Okay, so that particular device it is not mentioned in your textbook, but it's explained to you, thus you should know about it. Okay. Okay, so that is about the measurement of distance. Okay, for all these devices, you should keep in mind. Now, measurement of mass. How are you going to make the measurement of mass? Mass balance is there. Spring balance is there. Speed balance is there. All those can be used to measure mass, is like mass of a particular section. And how are you going to measure time? Stopwatch is there, timer is there, watch is there, clock is there, everything is there too. Time piece is there, everything can be used to measure time. So measurement of mass and time is not up to that much important. You just have to know that these devices can be used. That's it. Okay. So that's about mass and time. So length we said, mass we said, time we said, and now about the units. Now about the units. Okay. So what are the units in which we are going to measure distance? Yes, we are having several systems to measure, right? So first of all, if I am talking about length, what are the different unit systems over there? MKS will be there, FPS will be there, CGS will be there, and MPS is accepted as the SI unit, Systems International, right? SI unit. And FPS means, MKS means meter kilogram second. FPS means foot pound seconds. Now about CGS, it will be centimeter gram second. Okay, so this will be the three main unit systems which we have to study. Actually, we will be coming to this. It will ask the chapter again. Okay, These are the systems. Now tell me, what are the different units we can use for the measurement of length? Yes, we are having smaller as well as bigger measurements. Like if you start from a medium one, it is gonna be meter, right? Meter is gonna be the most used unit. Then higher to it, it will be kilogram will be there. Sorry, kilometer will be there. Then this how meter. Then is the deca equivalent. Yes, deca will be there. Then actually, I'm not writing in the order. Okay. I have to write in the order means I have to write deca first. Decameter will be there. Millimeter goes below me. Hectometer is there. Kilometer is there. Heptameter is there. Hecta is there. Because we can write it according to the zeros there. Now we can write infinite of them. Then kilometer will be there. Then miles will be there. Right? Now. Yes, we can write. According to the number of zeros, we can write. Centimeter comes below me. I'm talking about the higher units. Miles will be there. Then. Which one? Foot will be greater only. Foot will be there. Foot will be there. Then. Light years. Have you heard of light years? Light years will be there. Now, this amount of units is we measure between the planets. Or the sun from here, moon from here, we measure it light years. So such that like larger units will be there. Now coming to the smaller units, will be having centimeter will be there, millimeter will be there, micrometer will be there, nanometer will be there, Armstrong will be there, fermimeter will be there, picometer will be there. It will be going like this. Okay, small units will be there. So Armstrong error, na? Okay. So all these units will be there. Now we have to know the important conversions between these units. So because some of the unit conversions we require for all like not only for physics but also for maths or chemistry or something you will be having. Chemistry you will have a lot of places where you have to use this unit conversions. Okay, the chemistry is not something you have seen up to the 10th standard. It is going to be there in the 11th standard. It's entirely going to be different. You will have a lot of calculations to do there. Okay, fine. So tell me, what is centimeter to meter conversion? 1 centimeter equals how much meter? 10 to the power minus 2 meter, right? 1 centimeter is 1 by 100 meter. I mean, 1 by 100 meter is 10 to the power minus 2. So 1 millimeter will be 10 to the power minus 3 meter, right? Now 1 micrometer will be 10 to the power minus 6 meter, right? 1 nanometer, how much will be? 10 to the power minus 9 meter. What about 1 Armstrong? Minus 10 to the power minus 10 meter. Okay. Now what about 1 picometer? 10 to the power minus 12 meter. And what about 1 fermimeter? 10 to the power minus 15 meter. Okay, so it will be going like that. Don't have to set this pipeline for me now. Just go until Armstrong. Okay, Armstrong you will be needed in chemistry actually, not in physics. You need it in chemistry. We need it up to nanometer. Okay, so this is the smaller units. Now coming to the larger unit, 1 kilometer equal to how many centimeter? I mean, how many meter? 10 to the power minus plus only, na? 10 to the power 3 meter. Now, yes, we have to study this one. Now the unit. Okay. So all these conversion should be noted. Okay. So these are very important ones, and then there like nothing else, no? So conversion between systems we'll be studying after dimensions. Okay. So that is about length. Now tell me about mass. What are the units which we go for measurements in mass? Kilogram is the SI unit, right? So you'll be having higher ones will be. We'll be having like kilogram higher units or decagram. Decagram we can tell. Then yes, pounds can be said, tons can be said, right? Pounds will be there, tons will be there, like that it will be going. Okay. So lower, coming to lower, there will be gram will be there, milligram will be there, centigram will be there, microgram will be there, so this will be there. So that is the measurement for mass. And then about time, how many units will be there?
Second, that's all.
SI unit is second, of course. Minute will be there. Hours will be there. Days will be there. Yes, week will be there. Month will be there. Year will be there. Then decades will be there. Centuries will be there. Millennium will be there. It will be going like this. Actually, millennium only here. So below seconds, what will be there? We'll be having milliseconds. Milliseconds will be there. Microseconds will be there. Nanoseconds will be there. It will be going like this. Okay. So what is there will be time. Okay. Now conversion between second, minute, and hour is very, very important. How are you going to convert between second, minute, and
16:00.
1 second equals how many minutes? 1 by 60 minutes, right? Now 1 minute equals how many seconds? Sorry, how many hours? 1 by 60. 1 hour equals, sorry, 1 second equals how many hours? 1 by 16 to 60 actually, na? Should be 1 by 3600, right? You have to do it like that. Okay. And coming to the day relationship, day and hour relationship. So 1 hour equals dash day. It should be 1 by 24 because 24 hours makes up 1 day. Na? So 1 hour will be 1 by 24 days. Okay. So if you have 5 days, means how many hours will be there? 5 should be taken. Okay. So like that, you have to do it accordingly. Now time okay to you, mass is okay to you, length is also okay. Now conversions will be okay to you. Now, so can I start with the dimensions? Yes. So you can write the heading as dimensions. Angle measurements I'll be telling you. Radian measurement.
But these are
This one? So radian, that is angle units. That I'll be telling you. So because that is not this mark units or time. Yeah, that's why I was that's important. But you have to move it, right? Because coming to maths now, we will go for maths. Both have maths. No? Joshua also have maths side. So maths, you'll be having trigonometry. So last year when you studied trigonometry, you studied about sin 30, cos 30, tan 30, 60 and all. Now you'll be studying in terms of radians. No, theta only, but the angles will be radians. So instead of 30°, you will be writing it as pi by 6 radian. Instead of 60°, you will be writing it as pi by 3 radian. Okay, one thing I'll do. It is very easy only. It is not easy. Once you study radians, you won't be using degree. Okay, just before going into dimension, I'll just explain you the angle conversions. Okay, so coming to the angles. Okay, I think today we won't have much time to start with the dimensions also, right? Because the class is until 7 now. So we can go for the angles. Okay, so angle measurements I'll be telling it to you first before going into the for physics exam it won't be there, but it will be there in your maths. So it is my responsibility to tell you right. So angles. So measuring angles, you usually measure it using degree measures, right? You measure it as 0 degree, you will measure it as 30°, 60°, 90°, 45°, all degrees you know how to measure, right? You will be using a protractor to measure all these degree units. Okay. Now we are having another unit for angle, which is the SI unit. So, if someone asks what is the SI unit of angle means, you should tell that it is radian. It is not degree, it is radians. So, once you go outside India and tell degree, it won't be accepted in all the countries. In most of the countries, they will be using radian as the SI. Okay. So, SI unit is radian. So, what is this radian? What that we have to do? So, 0° is to be converted into radians. So fortunately, 0° is nothing but 0 radian. So how can we convert this? What is the definition? This one, this particular line. Or you can write it as RAD.
Sometimes use
Yes. I know, but still radian we usually have this particular line. Otherwise, if you're confused, means you can write it as RAD. Right?
also like
That is also there. Okay, so 0 RAD will be and 0 over here. Now, what is the conversion I'll tell you? If you have got some degree over there, if you have got something like you have to convert 30 degree, okay, you have to convert 30 degree into some radians. Okay, so what you have to do is you have to multiply this 30 with pi by 180. What is it? Pi by 180. Here pi is the radian measure of 180. Fact you should know that 180 degree means pi radians. Did you get it? 180 degree means pi radians. Got it? From here only we will be having the derivation of the formula. Okay, 22 by 7.14. Pi radian means 180. So pi is not this 3.14 or 22 by 7 which you have used all these days. Pi is a new thing. This is in radians. Okay. So pi radian means 180 degree. See, if I write pi radians equals 180 degree, then pi by 180 will give you 1 degree, right? Pi by 180 will give you 1 degree. If I write it as 180 degree, if I write it as 180 multiplied by 1 degree, it is same only. Now I am bringing this 180 to the LHS. Now what will happen? This multiplication of 180 coming to the side, it becomes divided by 180. Pi by 180 radian becomes 1 degree. So if you have 30 degree, what you should do? You should multiply this with 30. If you multiply LHS with 30, you have to multiply RHS also with 30. That is why 30 degree becomes equal to 30 into pi by 180 radian. Get it? So if you have to find 2 degree, you know this is the equation for it. That is 1 degree equals pi by 180 radian. Writing it again, 1 degree equals pi by 180 radian. Okay. So if you have to find 2 degree, what will you do? 2 into pi by 180. Right? If you have to find for 3 degree, it will be what? 3 into pi by. So here it will be 2 into pi by 180 radians. Okay, you can write this radian like this. I put like this is then just like this. Okay, just like the C over there. Then you won't be confused. So if you have to get what is 3 degree, then what will you do? 3 into pi by 180 radians. What is like that already but see, if you have to measure or if you have to say to someone that this particular radian is this much, then you have to know what is degree. See, for example, temperature, you use degree Celsius, right? But still you are using Kelvin as the SI unit. Why? When you go for outside India or outside Asia, the unit that is accepted is Kelvin. If you go to Africa and tell them about degree Celsius, they ask you why you're telling me degree Celsius. Not a standard unit, go for telling it in Kelvin. Okay, so if you go for using Fahrenheit, they just make you run out. But because they want Kelvin. Okay, so like that, in our looking in the world concept or universal concept, we'll be accepting radians more than degree. Okay, that is why we depend upon radians. So pi by 180 radians, we have to multiply for 30 degree means 30 into pi by 180. So the 0 and 0 gets cancelled now. So what is 18 cancelled by 3? It will be 6, right? So that is why 30 degree becomes equal to pi by 6 radians. Got it? Yes. Now, if I have to convert 60 degree into radians, what should I do? It should be 60 into pi by 180 radians, right? Yes, 0 cancels and it becomes 3. So 60 degree will be equal to nothing but pi by 3 radians. Got it? So if you have to convert 45 degree, what will happen? 45 into pi by 180. So this 180 and 45 gets cancelled with 9, right? Or you can cancel it with 45 itself. 45 into 2 is 90. So 45 into 4 will be 180. So it will be nothing but pi by 4 radians. Got it? Similarly, for 90 degree, what it will be 90 to pi by 180 degrees. So in this case, cancel that, it will be pi by 2 radians. Got it? Like that, you can convert any degrees into radians. You need it when you start studying mathematics. Okay, got it? So you can write the conversion formula very clearly. What is the conversion formula? X degree will be equal to x into pi by 180 radians. Okay. Now, if you have to convert in the reverse order, if you have to convert radian to degree, what we have to do then? You have to go for the reciprocal. Na? So, if you have y radians and you need to convert to degree, then y radians will be equal to y into 180 by pi degrees. Got it? You have to go for the reciprocal. Na? If you go for the cross multiplication, then only you will be getting it in radian.
Yes.
Just if you have confusion, please just remember, if pi comes in the numerator, then there should be radian. Okay? If 180 comes, it should be. So if you have to get the measurement in radian, go for multiplying it with pi by 180.
Always give us one.
This one?
They always give us the value of by x constant.
That will be given. 30 degree, then 30 into pi by 1. Pi by 6 radian means pi by 6 into 180 by 5. Just try for pi radians. So you have to identify how much is pi radians. What we have to do? Pi into 180 by pi, right? So if you go for cancelling this pi and pi, your answer will be what? 180 degrees. So pi radian will be equal to what? 180 degrees. Got it? If you have to go for 2 pi, you have to know how much degree is 2 pi. Then it will be 2 pi into 180 by pi, right? So this pi and pi gets cancelled. What is 2 into 180? It will be 360 degree, right? So 2 pi means what? 360. Clear, na? No problem, right? So this is the conversion formula. You can be
Pi. So there's 2 pi by 2. No, sorry.
it is in the equal to, na? It is LHS. Okay, so you have to note these two equations over there. Okay, so with these two equations, you will be able to convert. If you understand the equation of this equation, once you start already geometry in mathematics. So started it? Mathematics portion started?
Yes. Yeah.
Which chapter? Oh, directly to complex numbers. Okay, so let us see the rest of the next class. Okay, we'll be seeing about dimensions in the next class. You can study under this. If you have some doubt, please you can ask. Okay, thank you.
Okay.